시작하면 될 것 같아요.
All right, shall we begin? Thank you for coming. My name is Sang-ho Shin from SKT, and
My name is Daniel Park, also from SK Telecom.
so in this talk, we are going to talk about OpenStack networking solutions for telco infrastructure. And I'm going to talk about a little bit overview and introduction, and then he is going to talk more detail of our solution. Okay, so SKT. So how many people heard about SKT? Great, thank you, yeah. So we have been leading wireless technologies in Korea and also in worldwide. We've been like always first mover. Like we have first commercialized CDMA in worldwide. And also these days we have been deploying the LTA Pro. And then using that technology, actually we can reduce the end-to-end delay from the end user to the core in 20 milliseconds. It's almost edge. And of course we are preparing the 5G in next year. And as you may, all of you know, we have a Pyeongchang Winter Olympic in next year. So if you visit Korea, and then you should be able to experience some early stage 5G services. So please enjoy. Okay, so next. So to enable 5G service, we have been defining some open infrastructure for 5G. So it's about 2 years ago. So it's composed of some services, and we have defined S-Scale and Cosmos. S-Scale is about some telco infrastructure, about like structure and architecture of VNF, and some services, network slicing, and also operation. It's like we call it Tango. And this is my main topic of this session, and Cosmos. We have defined open infrastructure, open software-defined infrastructure. It's called Cosmos. It's composed of software-defined infrastructure using open software and open hardware. Okay. All right, thank you. So vision of Cosmos. Here we have physical resources, and we use open hardware like defined in OCP, Open Compute Project, and also TIP, it's Telco Infra Project. And on top of it, we use also some virtualization solutions, and we use fully open source, like OpenStack and some SDN solutions. So, and we have also some operation intelligence solutions beside of this. And in this talk, I'm going to talk more on like software-defined networking and some of the software-defined computing. Right, so open networking in Cosmos. So we have some infrastructure, like we have some servers, and on top of it, we have a leaf-spine L3 fabric. And to control this leaf-spine L3 fabric, we have implemented Sona Fabric. And this Sona Fabric controls this leaf-spine fabric, and it enables ECMP and some fault-tolerant solutions. And on top of it, we support the virtual networking management solutions. It's called Sona. And so maybe he's going to talk about detail about Sona and Sona Fabric. And we are deploying the Sona virtual networking solutions using OpenStack, of course. And we have also developed our own SKT version of OpenStack. It's called Taco. So actually, we have shown some live demo in yesterday. Have you seen the live demo of Taco yesterday? Oh, really? Oh, so most of you guys missed the excellent demo. Okay, so please don't forget to watch the video. So it's really excellent demo. So I'm going to talk about a little bit about Taco for you guys a little bit, and also you have a networking monitoring solution. It's called Tina. It collects all the physical networking data and also the virtual networking data from here, and it analyzes, and then it detects some network anomalies, some intrusions, and then also it visualizes using 3DB. So he's going to show some demo of the 3DB. You will love it. You will love it, I'm sure. All right, so I'm going to a little bit talk about Taco. Okay, Taco. So this is the first announcement of Taco logo. This is our Taco logo. So what this looks like? Okay, containers, right? Yes. Okay, great. Yeah. So we are deploying the OpenStack fully using containers, utilizing Kubernetes and like Cola and OpenStack Helm projects. That's our key feature. A little bit detail, okay. So this is kind of SKT version of Taco, the OpenStack, and then we are using Kubernetes and using OpenStack Helm chart, and every OpenStack component is containerized using Cola, and also using this kind of container like some technologies. It supports self-healing. Also, we can upgrade without any service interruption. And also, it takes only a few minutes to deploy the full stack of OpenStack. So if you see the demo, and then you can really see it. All right. So how do you do it? So we actually do not touch any OpenStack source code. We fully use open source code, the upstream code of the OpenStack source code. Also, we use the exactly same source code of Kubernetes. And Sona we have developed is already upstreamed in actually its own. So he's going to talk about that a little bit. And then we just define our configuration, depending on kind of deployments. So we just combine the open source code and our configuration, and we are using Jenkins to deploy it. And then we do packaging and testing like almost every day. And then we can really easily deploy any site. Like we have Sona here, and also we support like software-defined storage. It's called Ceph, and using OpenStack. So this is basic, the architecture of this Taco. So please don't forget to watch the Taco live show video later. Okay, and then he's going to talk about Sona and Sona Fabric in detail from now. Okay, so before that, I'm going to talk about a little bit like ONOS architecture. So I know that you guys know ODL and OBS, yeah. But have you heard of ONOS? Wow. But still, we need to more work on ONOS. Because I was surprised that like in every slides they are showing, we are mentioning the backend of OpenStack networking, ODL and OBN, everything. But I've never seen the ONOS yet. Okay, so ONOS is kind of it's a carrier-grade networking operating system. It has been released. We have released the first version of the ONOS in 2015, almost 2 years ago. So now we have 10th version of the ONOS. It's led by the ONF. Actually, ONLab was reading the development of the ONOS, and now ONLab has been merged to ONF. So basically now ONF is reading this development of the ONOS. However, this is the fully open source. So actually many companies are participating to develop this, like Verizon, Google, and Samsung. Every major vendors, every major ISPs are joining to develop ONOS. And the key feature of the ONOS is that it supports kind of scalability in Braun. ONOS basically supports clustering. So it supports a high scalability and HA and everything, and with the very high speed. And that's kind of a key feature of the ONOS. And then Also, it supports variety of the southbound. For now, it started from the OpenFlow. Now it supports netconf, OpenConfig, P4, and everything. And also, it provides a kind of many kinds of northbound APIs, so that we can really write our own application very easily. And also, we have implemented Sona and Sona Fabric using ONOS. ONOS. Okay. And then he's going to talk about Sona and Sona Fabric.
Hi, I'm Daniel Park again. Actually, I am a major developer of Sona project. Sona simply means simplified overlay network architecture. It's basically ONOS and OpenStack integration solution. And gives some SDN network virtualization to OpenStack. So it is designed for, it is networking architecture designed for providing optimized network virtualization solution in an efficient way. So it is developed on top of ONOS, and it's fully open source. And every single source codes are upstreamed to ONOS repository, so you can easily download our Sona source code from ONOS repository. So it's, it has been 3 years to develop a Sona project. So it's kind of ONOS's official use cases. So if you have a chance to connect to the ONOS wiki site, at the apps and use cases tab, you can find Sona project. This is the Sona architecture. If you look into it, there's an OpenStack here, and Sona here inside of ONOS, and there's a bunch of compute nodes and gateway node groups. There are three kind of Sona applications in ONOS. This is the OpenStack node application. What it does is that it initializes compute node and gateway nodes, which means that it creates BLint on the compute nodes, and BLint and BLrouter bridge in gateway node groups, and create a VxLAN-based tunnel between them. So after that, when Nobel provisions virtual machine, then neutron API events occurs, and there's some kind of networking ONOS OpenStack package, which is ML2 plugin, and this transmit every neutron API event to OpenStack networking, and OpenStack networking receiving that neutron message, sets flow rules about switching and routing flow rules to compute nodes and gateway nodes. So you can find this VRouter application on top of ONOS, combination with VRouter and Quagga and BLrouter. We can make this gateway node to play like BGP router and OpenStack neutron network node, something like that, and DNAT and firewalling or something like that. So also this year we developed some kind of UI for flow trace for debugging purpose. So this is the key features of Sona project. Basically, it implements OpenStack neutron plugin. In other words, ML2 plugin ML2 mechanism drivers, L3 and security groups, and LB Azure services. So to do that, we use networking ONOS project. Actually, this is initially developed by Huawei guys, and now we take that project. We'd like to take the project and develop some additional features to that networking ONOS project. So anyway, this is OpenStack package for exchanging neutron events between ONOS and OpenStack neutron. So also, Sona project supports VxLAN-based network virtualization, and it's fully support fully support OpenStack network neutron model, and also we support VLAN also. And you know when you install neutron, you can find there are so many agents here. DHCP and OVS and L3 and L2, something like that. So if you install the Sona, then there you can find no agents here, and there's no network node. Also, instead of providing network node, we develop our own virtual router, which you see before, and we support scalability for virtual router. Also, we support optimized east-west routing, which means that no virtual router needed for kind of traffic from between VMs from different kind of virtual networks. Also, we support UI-based flow tracer. This is very humble owner's GUI. You can see these 5 compute nodes. It is real environment. We use that infrastructure for our development purpose. In this GUI, you can find 5 compute nodes and 2 scalable gateway nodes, and there is a bunch of VMs here connected to virtual switch. And there direct communication occurs when the traffic occurs between VMs from different networks and same networks. Also, we support gateway scalability, which means that if we want to, if we need another north-south bandwidth, we can linearly add our scalable gateway to OpenStack. This is the new feature of Sona Project. You can see in this box. You can see the flowers inside of the compute nodes, which means that when you have a network problem, instead of using kind of these dirty things like typing sudo ofctl dump flows minus option openflow 1.3 bl int and grab something. Yeah, the intention to make our the GUI is that I hate this. So when you have a network problem, we should type kind of these things, and we have very eagle eye, and we can finally find what's the problem. But it's really hard to see what's the problem. So this year I developed that GUI. Yeah, I'm angry about that. So this is the GUI demo video. We can turn on Sona GUI Overlay mode. Then you can find the GUI change it. This is the developed on top of owner's official GUI. So when you mouse over some VMs, you can see the VMs which belong to same virtual networks. Also, you can see these numbers. This number means VxLAN ID. Also, if you mouse over the virtual switch, you can see all the VMs connected to virtual switch and different VxLAN IDs. And if you click some VMs, this one, then you can see summary information of the VMs, MAC address, IP address, VNI, and you can see there's 4 buttons. One is flow trace and reset, and trace to gateway, and trace to external. You can perform the trace test using GUI. Then now I select something, and this is the destination VM. Then some box here, and I request the trace from this IP into this IP. Then request, I got some result about flow rules. You can see exact flow rules, how the packet comes in. So in port 34, go to tab 1, 3, 4, 5. Finally, go to another node by 3xN tunnel. Yeah. Then you can perform trace to gateway, which means this. So you can find the flow rules. What you need is. Actually, this is a this VM has no floating IP. The packet, first packet comes to transmit to the owners from gateway nodes. And maybe this VM has some floating IP, so the packet goes to external directly using floating IP. And also, when there is some problem, this VM has no external connection here. So I test external, and sorry, this is not. This is also has some floating IP features. Floating IP. This is floating IP. I'm sure this VM has no external connections here. So you can see red box, and then what flow rules has a problem. So you can find what's the problem and fix it easily, not using CLI or something like that. Also, using this GUI, you can see the statistics, packet per second and bit per second something. Yeah, that's all. So let's discuss about use cases for Sona project. Definitely, we can think of adoption Sona to telco network. Suppose we finally push some vendors to make their EPC functions as a fully cloud-native way. So we can construct cloud-native telco data center, and every functions are virtualized. And then, what benefits could we get from this data center? You know, it is very, telco data center and cloud data center are very different situation. So the benefit could be very different compared to cloud data center. So what benefits could you get from this data center, telco data center? Number one benefit definitely could be, I think, fine-grained QoS. We can split out this full infrastructure to some network slices, different network slices, as many as we can make. And we can provide a fine-grained QoS to each different network slices. So using Sona, you can differentiate the QoS between network slices in the same infrastructure. Also, Sona is based on ONOS open networking operating system. So we can make another good application to control other infrastructure, such as Fabric and servers or something like that. Another is maybe VNF onboarding. In edge term, XOS means XOS is a VNF manager in edge term. XOS is open source project which is initialized by Princeton University and now maintained by UN Lab. So XOS is a VNF manager, and so XOS now supports LB as a service and Firewall as a service in OpenStack Neutron. So this onboards this VNF as a VNF manager, and this goes to Docker Swarm, and Docker Swarm deploys this VNF as a containerized manner, and then Courier helps connect to VNF connected to the same network slice where the virtualization VNF lives, which means the Courier makes some API message to Neutron, and Neutron receiving that message, and Neutron transfer that message to Sona, and Sona makes all connection between these VMs and these containers all together. So this is the Sona Fabric. So far, I introduced, I shared with you about the virtual network world. Sona Fabric is for physical fabric world. suppose this is OpenFlow switch, like H-Core and Cisco Nexus and Arista with OpenFlow enabled. So this is a pure OpenFlow-based leaf-spine fabric solution developed on top of ONOS, and it supports ECMP and failure detection and auto recovery when switch has some problem. Also, integrating Sona Fabric and Sona together, we can make some fine-grained QoS all together, not a separate way. Also, nowadays we are testing some physical switches, Cisco, Arista, H-Core, and something like that. I'm not sure this switches supports OpenFlow well right now, but we are talking together to Cisco and Arista guys to fix the OpenFlow features. 1.3. This when SDN-based data center transformation is done, we can control our whole data center like this: server and network and one shot. So please see this video.
천천히 하면 돼요. 저기 왼쪽에 위에 그거.
Yes. This is a demo of our 3D-based network virtualization and network visualization, and we have 7 data centers in Korea. This is a very small country, right? Then you can see summary information about the data center. And if you click some specific data center, you can see bunch of racks and switches. And there's some fire here. Maybe we need some firefighter to extinguish this rack. And this is spine fabric. And if you click the rack, and you can see summary information, the bandwidth and status about that. So if you drill down, you can see switches and servers and statistics and port information. So up, down, something like that. Also, if you click this, usage.
뒤에는 조금 빨리 할 것 같아요. Skip it.
Also, seems like there's some problem. Switch turns red. So we click this. CPU goes high, so we need to scale out some VM to another servers. So anyway, with SDN, we can fully control the servers and networks all together with 3D-based manner. So because of time frame, I should cut this. Then let's go back to the presentation.
All right. So we have been talking about the control plane of OpenStack and control plane of networking. So what's missing now? Data plane. So data plane. So actually, we have no clear solution for data plane, at least for telco. So what does it mean by that? So actually, the virtualization is not really silver bullet for for direct TCO reduction for telco for now, at least for now. But still, but actually, the operation guys know that virtualization is kind of a way to go. So they don't say no, they say yes, but they still resist kind of still same performance as the physical network functions. It's like there's no packet loss and full line rate and no extra CPU usage For now, it's really difficult to achieve meet those three requirements. So for now, the available solutions are data plane acceleration. As everybody knows, we are trying to maybe OBS-DBTK and legal flooding and Xeon-based FPGA solution, maybe with Intel or some other vendors. And next, in this next year, actually, we have been already doing this. We're gonna do some commercial level POC with real VNF. We have chosen the DPI for now, and we are going to do real commercial grade POC with VDPI on top of Taco and Sona and some of the DPA solutions. So hopefully we should be able to have a chance to give a talk about result of this POC maybe next year. Okay, and the summary. Okay, so we have the open networking is really essential for 5G, and then we have developed Sona and Taco, and we are going to do real POC, and we're gonna show some results in next year. Right, thanks so much, and have a good lunch. Any QA? Nope.